Yep.
Yep. Is that purely relevant to turbocharging and supercharging? Could you exceed those figures with the naturally aspirated engine? Mm-hmm.
Yeah.
Yeah, good. Yeah. Mm-hmm.
Yeah, I think that's in 11p, but not 12p.
Mm-hmm.
Can I have an example on that? Because that's something that I'm struggling with. I see a MAF as an intake restriction, not something that can control the engine better.
They also adapt to small changes with the engine a lot better than MAP does.
So would you say that the main benefit of a MAF is improvement of drivability and efficiency rather than out and out performance? Mm-hmm.
Yeah, can I say one thing about the map versus MAF? The MAF actually measures the direct quantity of air going into the engine, like the mass of the air. So it's able to adjust for altitude, temperature, humidity, and all that sort of stuff. So it's directly feeding information into the ECU about how much air is going in, where the MAP system works on kind of like it measures pressure in the manifold, and then from there it actually calculates. The ECU will calculate from its code how much air will be going in based on assumptions of like what the ideal gas law or something like that. Yeah. Yeah, as I found, like even small changes on a map-based system needs retuning, where on a MAF you could say, put on rockers or even like a good exhaust or something. And usually the MAF-based system will actually accommodate for that.
Yeah, when you change, if you do minor porting or anything like that, you don't have to adjust the VE table because the MAF is telling you exactly how much air is going in, not whereas with a MAP it relies on the VE table and the MAP sensor to get that same information.
Yeah, that's right. Like I just took out the bell mouth out of my VR and I tuned it today, and I did actually find there was differences. Not huge, but they did affect the overall like air-fuel ratios that were reading in certain points of the map. So yeah, that's just a minor thing, and that changed it quite a bit.
So just much more adaptable.
Sorry, Nigel. Can I butt in for a sec? I just after everyone's thoughts on. It's a popular modification to do a MAFless tune on an LS1, let's say, but in the States that's not popular. It's popular to tune the MAF. Why would that be? I mean, obviously you've pointed out the benefits of the MAF, now, but why in Australia do people throw it over the shoulder?
Can I
they-
answer that, because I know a bit about that. The LS1 that we all get in Australia is the MAF is restrictive from the factory. Out of a bog stock LS1, the airflow meter actually restricts the amount of horsepower, and that is why the easiest thing for people to do is throw it in the bin, tune the VE table, say happy days, and they go away. Where in the States, they've mostly moved past that generation of engine, and once you get to the LS2, the airflow meter is actually big enough to accommodate the engine from factory. So there's no benefit to removing it. So they just tune it in, and that's.
Is there much success in tuning to a different MAF?
The main point is ease. There is no outright power benefit to it, and it's so much easier for a lot of tuners to throw the MAF in the bin and then just tune the VE table like they used to, and that's why they all do it. Whereas if you put a MAF on, then you've either got to find a pre-calibrated MAF table or do it yourself, and a lot of them are so used to doing MAFless that they just keep doing it, even though it may not necessarily be better. But the only benefits you're going to get in keeping a MAF is going to be in drivability and economy, but your outright power is going to be no different at all.
I'd love to have a lesson in MAF changes, MAF scaling, and all that sort of stuff. I've got absolutely no idea with that.
Yeah, I'm in the same bin really.
Laminar, yeah.
You can also do it by sticking your new and your old one in series and with the data logger. That's how I did the MAF learn code for the Motronics. You stick your new one in front and drive around for a while, and it builds a new MAF table for you.
Definitely.
Nah.
No,
No.
they're all batch fire anyway, so it's irrelevant. Could we go back to what the point of looking at end of injection is? Because I don't think a lot of people would understand that. Because I watched a video that sort of explained it very well. In that the whole point of buggering with end of injection is your very low load quality, idle quality, essentially, because on a big camshaft, the inlet and exhaust valve are open at the same time. So if you inject your fuel early, then your fuel is shoving it out the exhaust, and you're getting raw fuel going out the exhaust, and that's why they all smell fuely. Whereas if you make your end of injection later, then by the time the exhaust valve is already closed, then your injector fires, and then all your fuel stays in your cylinder. And that's the whole point of buggering with this at all.
So you'd obviously tune this throughout the rev range, not just for idle quality.
What you got to remember though is your injector. Say you get up to 80% duty cycle. That means for inlet opening, inlet closing, exhaust opening, like you're all the way open during that entire event anyway. So when it fires, becomes a lot less important at high load because it's always open anyway.
Yeah.
Yeah, that's kind of like
The valve overlap at idle is a good point, though. I hadn't thought about that.
And that was it was explained in the video that the way you get it really good at idle is you run it in real time and you alter the end of injection and you look on your wideband, because more fuel is staying in the cylinder, more fuel is burning, and it alters the reading on your wideband.
I was actually going to ask that. Which way does it affect it?
I forget.
From what I've seen, if you've got raw fuel going into your exhaust, it says it's lean.
Not necessarily. It doesn't change the amount of air coming out. It changes the amount of fuel that is staying in the cylinder. So when there's raw fuel coming out, it may read. It's actually going to read richer when
But if
But
there's
it
raw
hasn't-
fuel coming out, it means that that fuel hasn't burnt, and if you've got the correct
you're-
amount of fuel going in, then it is actually burning lean.
Yeah, I
Yeah,
would think
you're right.
lean as
It'll
well.
be rich. It'll read lean, and it will richen up. It will read richer as you get closer to your ideal end of injection event.
Because the oxygen's being consumed, obviously, when it's burning, rather than just being like in a vapor form in the exhaust. So
Yeah.
does that kind of make sense? Yeah, that's what I think anyway.
Mm.
Maybe transmission tuning. Like it's just a quick touch on that.
Did you? Did your brain hurt when you looked through all the oil flow diagrams?
Yeah.
I mean, my head hurts bad enough when I look at the T5. I can't imagine. I can't imagine building one of these.
Mhm.
So all the shitbox Commodores that I've ever had come in the workshop with a shift kitted or modified auto that thump and bang. It's doing that because they've been poorly tuned in this regard.
That's can I step in there a little bit? A lot of people don't really know this, but on a 4L60E, there's a little hex nut that alters the overall. It manually alters the pressure in the box, and what that's actually for is from factory. They use that to calibrate. When the ECU is commanding 90, then they calibrate it so it's actually 90 in the box, for example. And then an auto shop can go, oh, the pressure's a bit low in this box, I'm going to screw it up. So independently of the calibration, they might screw another 10 psi onto that screw. So when the ECU thinks it's only 90, it's really 100 now. And that's when you get screw it around probably half a turn, and you'll start getting it thumping into D all the time. And that's sort of what a lot of the problems are. So if you get one that's been screwed up real high, then it's pan off, 3 bolts off, where those 3 bolts that pull one of the pistons out, and then just behind on the back of one of the solenoids is a little a little hex nut that you can back off. Yeah. That's,
Of course, there's another problem there too, Nigel, is that the very time that some tuner comes along and starts playing with the transmission settings, it often can void the warranty in many of these transmissions. So you've got to be very careful what you're doing. It pays to get permission from these people that rebuilt the thing, and if they're okay with it, that's fine. But otherwise, they can certainly blame you for what goes on. You know. Because the other thing too, which is rather strange, is that for many, many years, of course, these transmission guys have been making these mods long before we had the software, and yet you never come across a transmission guy. I haven't anyway. The guy that's doing mechanical work and he's got the software as well. I mean, you can't beat that combination, but I've never seen it. Yeah. Actually, there's one. Sorry to interrupt you. There's one very common problem that I come across, and I'm sure other guys on here have too, and that's the thing called Code 68. And Code 68 on the early transmissions is basically a component slipping in the transmission. And Holden were aware of this. It was a design problem from the engineers. They made the tolerances far too small, and the box only had to wear, or the torque converter had to slip just a little tiny bit, and all of a sudden the engine light comes on and you've got Code 68. Well, the transmission guys love this. I mean, this was a $2,000 job for them. And I used to approach some of these transmission guys and say, listen, I've got a good fix for this. I've got a Memcal here, cost you $100, and save the customer a lot of money. And he would say, listen, we don't want to know about that. We want to pull the box out. We want to make $2,000 on it. Yes, that's what happens, yeah.
but that's what Holden actually did. In the later calibrations, Holden disabled Code 68 themselves.
Yes, that's quite true.
It's not being dodgy or anything. It's Holden's fix.
Yep.
Mm.
I believe that, yeah. Well, also, what about all these fan temperatures coming on at 110? I mean, any Australian wouldn't design that for our country, you know.
Yeah, I thought that was ridiculous.
And you
Oh, yeah, they would have done. Yeah.
Mhm. And you can't even edit that in an Alloytech. There's nowhere in the Alloytech tune that you can edit where the fan comes on, because I tried to do it on my bloody own and you can't.
Mm.
So, yeah, so one other thing that I could give, a piece of advice I can give for people looking at this sort of stuff on 460Es is don't trust your dipstick as to be gospel, because they like to be about 500 mils over full. If it's slipping, you can put 500 mils of oil in it and it doesn't slip anymore.
Yeah,
Yeah,
I
I can vouch for
found
that.
as well. Yeah, I've seen that.
I am, yes. Yep. Yeah, I agree.
So, sorry, just with that force motor adjustment in the box, would it be advisable then to put a pressure gauge on the box and make sure that what's in the calibration matches what the box is actually doing? Mm-hmm. Yep. Yep.
The force motor does change the pump pressure too, because the way it works, as far as I've seen. But the catch, the biggest catch is the ECU doesn't actually know what pressure the box is running. There's no pressure gauge. All the ECU knows is 0.68 amps is supposed to be 90 psi, because they're assuming that the bolt on the back of the force motor has been calibrated correctly and not been fucked with by some happy auto technician. So it is advisable to an extent to make sure that you're not running pressure through the roof, but you'll find that there's guides online as to what your pressure should be in D and neutral and R with a gauge. And I've had a gauge on the side of a few boxes to actually look at that, and it does go. It goes through the roof in reverse though, but that's normal. But I found all this out the hard way, because I actually made a transmission controller of my own and eventually gave up and decided it was so much easier to use 11P when that came out.
Yeah, do we need a PhD for this?
Yes.
Yeah, it's a,
Yeah, yeah, yeah. Do a run over of that. Is it similar to 12P or is it different? Tuner Pro.
What is it?
Um,
Mm-hmm.
There's a lot more to actually use it for if you do, depending on how much you use 12p and 11p, because I use 12p and 11p more than any other thing, and every single vehicle I tune, I'll use this flash tool, because you can make a bin up and then flash the calibration in using this tool before you start, and then at the end, when you're ready to burn it, then you open this tool and get the full bin out, and then use the bin out of this flash tool to burn back to your memcal to give to the customer. And if you need to edit any of the flexible output items or the ALDL data stream of 12p or 11p, all of that is in this tool. So if you're using 12p or 11p, you will be using this flash tool a lot.
Yeah, you can also use it to migrate to different versions as well. Yeah, so I've used it a couple of times. Yeah. I found it a handy tool also to just to suss out what is going on with, like, say if you have a ECU that's stopped working for whatever reason, you can check if your MV RAM has gone wrong or something, and I've used that to check it. Where like Tuner Pro wouldn't do anything. This allowed me to see that some of the data, it was sort of working, but it was corrupt. So yeah, it was useful. So
Just
you
to
could,
clarify, you're taking a read of the bin via the ALDL?
yep.
But this thing will actually get the full bin of anything from VR, all the VR and onwards in the map-based PCMs. This will get you the full bin. Very, very handy for those aftermarket memcals that are scrambled that you can't actually read in a burner. You can a lot of the time read it out using the flash tool, because the ECU is kind enough to decrypt it for you, and you're just pulling it out of RAM. So,
I think we've got a solution for that Crow Cams memcal we're looking at, Vlad.
Yeah. Yeah, we'll have a look at it.
yeah,
Yeah.
that'll work for pretty much all of those. The Crow Cams memcals, you'll just pull it straight out with the flash tool, because it depends though. If it's a VN based tune that they've burned onto it, there's no 8192 board ALDL, so you can't use the flash tool. But if it's based off of VR or later in the program, then you'll read it straight out.
Mm-hmm.
We could always give it a shot.
Yep.
Hey, Gareth, have you got the Memcal adapter for the programmer?
Definitely, yeah.
Yeah, you could just read it that way.
No, I've tried. It wouldn't.
No, there's an address scrambler underneath. What I've looked into this to play around with decrypting one myself a bit. What there is that there's a little intelligence little chip. I don't actually know what to call it or what it does, but under the memcal, it looks at what address lines are being read, so you have to actually read the EEPROM in a certain order, and as you read each pin, it will remap it underneath and allow you to read the next bit. So it knows what order an ECU reads the bin in. It always looks at the reset vector first, which is at the very end of the bin, and then it reads backwards, whereas an EEPROM will start at the beginning and read all the way to the end. So it can detect it. It can detect that, and it will leave it all scrambled when you're reading from start to finish, and it will only unlock the correct address lines if you've read the reset vector first and then gone to the beginning of the code and read it in the order that an ECU will read it.
What school did you go to learn all of that?
Called my life.
That's exactly it. I actually managed to read enough of a memcal by looking at where the reset vector was and putting that offset into the burning software, and you can read that bit first, and that'll get you a little bit of the bin unscrambled, and then you can figure out where you need to read next to get the next bit.
Jesus Christ.
It's a mind bend, I'll tell you that. The easiest way is just to plug it in and use the flash tool.
What a headache just listening to that.
There's a company called EVC which make a lot of they make a lot of the I think they make WinOLS among other things, but they have a whole range of hardware encryption sockets for protecting things. Key 101 is one of their more famous one, and I spent quite a while trying to reverse engineer one of those, and it ended up being that their version actually just looks for the timing of the toggling of the OE line, using the basis of an EEPROM programmer will toggle the OE line between reads, whereas an ECU won't. And yeah, managed to decrypt a whole bunch of the stuff protected with their bins using that way, because their modules have an individual encryption key per vendor that they sell the things to. So just because you if you reverse engineer one, it won't work for one of their modules that they sold to someone else. They were real painful, those ones.
Yeah, this leads me to a question. Why would Crowcams try to protect their calibrations if it's so terrible?
Yeah, well, the last...
What you find is the worse the tune is, the more they try to protect it.
Yeah, I agree with that. Yeah.
Yeah. Like a dodgy builder.
Jeez.
Yep.
Mm. Yeah, I've actually got a question for him when we do one.
I'll ask it here if you want, because a few of us use the 12P a lot.
Yeah, well, I know that I sort of not me directly discovered a problem, but Ryan picked up on it when I was doing the tuning on my VR a while ago. That because I'm at a higher altitude, the I think it was the ADX or something didn't scale the log, the table that it logged versus what it would actually do in the ECU. So every
Yeah.
time I logged, I would only get up to like 90 kPa when the ECU would actually scale to the 100 kPa within the
That
actual ECU.
was actually added into 11p version 104, I believe, because of that same reason. The ECU scales the map, whereas the ADX was just reading the raw map.
Yeah.
But in 11p 104, it is actually scaled now. But I'm not sure whether he edited 12p or not.
Yeah, he said he did it, and I got an updated ADX, and then version 1.12 came out, which already included the fix that I got beforehand. And I noticed that sometimes it works and sometimes it doesn't. Like in the recent days, I've been tuning it hasn't worked. What I've had to do is copy the 90 kPa and 95 kPa row, column, and chuck it into the 100, and then I'd get an accurate log the next time round. But if I kept just putting in what it was logging, eventually my tune would get further and further out every time I logged it. It'd get
that's definitely something for Ryan.
Yeah, I'll have to pick his brain on that one. Yeah, and the whole the baro as well, like the barometric pressure. Sometimes I'd get 104 when I'd start up the key, which is odd because that's what happened when the first time I got my once he tinkered with the ADX and said, yeah, give this a go. It would always just default to 104. I guess that's the maximum value it can be, and then that's. Yeah. Yeah, so what it was doing was going to 104 most times, but sometimes it would just give me the actual barometric pressure, like 96 or whatever, and when it would give me the actual one, that's when it wouldn't do it properly. So I don't know, it's like it's half working, half not. Sometimes it works and sometimes it doesn't.
Sounds like a bit of a code bug to me.
Yeah.
Could be a cheap map sensor.
Turbo in there?
Sorry?
Are you running a turbo?
No.
NA.
NA.
Because there was, I remember that there was some code in there for the forced induction where it wouldn't. You had an option of not recalculating barometric pressure during a run.
Yeah,
mine's
there's an option to be during a run or on key on. Mine's
just start.
Yeah, just start. Yeah.
Okay. Well, if you're NA, why not? Have you tried it the other way during a run?
Yeah, I might do that tomorrow. I might give it a go just to see what happens.
It shouldn't have any negative impact if you're not forced induction.
Yeah, it should be alright, I think. I mean, I do open full throttle enough times for it to update it, so it should be alright.
Sorry, officer. I was just giving my ECU some good data.
Yeah.
So can I have a question for Dick? What's this 30 hertz logging you were talking about on the forum that you were going to talk about?
Yeah, okay. We did some testing today with one of our members, Peter Callow. I'm not sure if you know him. He's 0081. He actually lives very close to me, and we did some tests today. And what I discovered is I wasn't aware of that the offset in the enhanced programs, the offset's only 1, whereas on the earlier programs there's an offset of 3. I don't know the reason for that, but maybe Nigel can explain that. As the payload, remember that the body length versus the payload, and in the earlier versions, which I've been more aware of or used to, with the coding I've been playing with, it's always been an offset of 3, and of course I tried to use 3 and it didn't work. I had some problems with it, but I've overcome the problem. I've actually gone back and used the same offset that you've been using, and yeah.
Yeah. The 3 should be the standard ALDL message header. So
yes.
1 Yeah, well, that's interesting. If you're only seeing one, maybe with the flash tool, capture some of the some of the packets that are coming through, and see what's going on.
Well, actually, yeah. I mean, Nigel, that is Nigel's program, and the offset is definitely one. I don't know.
It's not something like the OSC plugin stripping off the header bytes or anything.
No, it doesn't do that. It sounds more like maybe. See, the offset it only changes where the body of the message, where the first byte is. So you could technically use an offset of 0 and just move all of your items up a couple of bytes in your addressing.
So you're saying that the first data byte address that as byte 3 in the body to overcome. Yeah, okay.
Exactly. It sounds to me like it's something more like that going on. So it's different authors of different ADXs. They may have just done it differently.
Because I did notice that on the very early ADXs, which were called something like $6060A, you might recognise that number. They were very early ADXs. Now all of those are all have the same offset of 3, and just the more recent ones that I've been looking at are 1. So it doesn't matter. I've certainly have solved that particular problem, so I'm sort of continuing. But what we're basically doing is we're actually just shortening the actual string up. That's all we're doing. And yeah, exactly. It took a while to work out how to do it, but I mean, once it's fairly easy once you've learned how to do it. And I've got to talk to Ryan and see if he'd be kind enough to add it to his flash tool.
So you're kind of making your own message 6 kind of system.
Yeah, exactly. Well, it can be anything. You can actually could be a message 6, 7, whatever you want to make it. You know.
Yeah, but a short custom message of nice and fast, just the data you want.
Yeah, well, I'm actually getting 30 hertz out of it, and of course, when you're looking at logs, it certainly helps. Yeah. So. Actually, the other thing I wanted to mention too is that I've noticed there was, as you know, there was a post up about knock sensing with regards knock sensor and the knock counts, and I've looked through a lot of the CalMaker stuff in the VY, and there's no logging of it at all, at 0. There is no log counts, and I'm very curious to see if we can actually find that in the code. Yes, yeah. Yep, just the rolling counter, yeah. Because that... Yeah, okay, yeah. But because what's strange about it is, as you know, most of those tables in the VYs are using knock counts, you know, for their noise levels and background noise levels. So, yeah, so... I guess what I'll have to do is need to go through all the memories I can find and see if I can find something that looks like knock counts, that's all. But it's very difficult on the bench, you know. But I'll be sending you that program very soon, by the way, too. Yep.
Let us know where you put this recording, because I dropped out halfway through. Okay. Yeah, everybody was there, and all of a sudden everybody wasn't, and I nearly threw my modem through the window. Yeah, no, that'll be handy.
Actually, that's one thing. Does Camtasia actually record your own voice through the microphone? Because I can't actually hear my own voice. I can only hear you guys. So if I was inputs as well.
If not, otherwise you just have to do a voiceover afterwards.
I certainly think this has been a fantastic thing. I think it's worked way better than what certainly I expected. And just while I've got the microphone for a sec, I'd just like to take this opportunity to thank you, Nigel, for taking the time to do this. This has been great. And for everyone else's input too.
Yeah.
Yeah, we all bite.
Yeah, thanks, Nigel. I've got a whole stack of VS ECUs and never actually looked at them or anything. So yeah, it's sort of opening my eyes to the whole world of MAF and auto gearboxes.
Going back to the MAF versus map, my general consensus was that the map system is faster responding. Is that true, or is that more just an urban myth?
That's been my experience as well. You'll find on, say, a factory Ecotech, if you flatten it, then there's a certain amount of responsive there, like a little delay before it'll actually go, and possibly able to be tuned out. But that's because of the, as far as I know, is the delay between when you flatten it, it sucks all the air out of the plenum, and it has to make that wave has to make it all the way back to your MAF, and then your MAF can start reading the air and the fuel increases. Whereas if you have a map sensor, it will read instantly the drop in pressure in your plenum, and then the fuel gets injected extra straight away. But anyway, I've found if you take an Ecotech and throw a map-based computer on it, your throttle response is a lot better.
Yeah.
So I've found out of experience that, yeah, that's true.
Yeah, because I'm. It is. So is that kind of like reading the TPS movements and then sort of and anticipating what will actually happen after? Mm. Mm.
Same goes for forced induction. It's exactly the same for forced induction. Even on the old Turbo 700s, it's the same. If you're on boost at 50% throttle, you've got a lot more torque going through your engine, but everything's calibrated to back the pressure off at that point, and then you get slipping and gear changes. So.
Mm.
I was going to say a few words about bench harnesses. I found through the years you can learn an enormous amount on the bench. For example, something very simple is you'll get hold of the throttle one day and just move it, and you'll notice the injectors will fire just by touching the throttle. And a lot of people don't realise is that as you move that, it's putting like extra injection pulses in at the same time.
Oh, I have seen that.
Yeah.
Yeah, it's interesting. I think on a really old Volkswagen Type 3, which was the first production cars to ever have EFI, I remember seeing that, and it was pretty cool. You just turn the throttle and you hear the injector sort of like pulse.
Yep.
Even if the engine's not running on those.
Yeah.
So, was that an LJet?
Sorry?
The Volkswagen Type 3, was that an LJetronic it used?
D-Jetronic, the first.
Oh.
First generation. So yeah.
Yeah. Okay.
I just threw up in my mouth a bit.
Yeah. I thought LJets were bad. Yeah. Well, it could be worse. It could be K-Jet. I worked in one of those a while ago.
Actually, the D-Jet wasn't too bad. It was kind of similar to like the 808. It just had a map-based system, and that's pretty much it. A TPS, temperature sensor.
Lack of fault codes.
Oh, it had no fault codes.
Lack of a processor.
Yeah.
It had
It was an analog system.
Yeah, I counted. Get this, 12 transistors. That's high tech.
You want to raise the rev limit? Well, you change this resistor here.
Oh god.
Yeah, they were only about the size of like oh, how big? They were probably like 300
A small
mil.
Volkswagen. Yeah.
Yes. It's funny. It actually has the diagnostic plugs on those cars, but they were kind of like a complete car diagnostic for like checking shorts, like if indicators work. It didn't really tie in with the ECU so much, but they were pretty big. They were about a little bit bigger than the was it the 424 ECU? Probably a little bit bigger than that. Yeah, but they were dumb ECUs. They didn't really. They're just an analog computer. But that was my first experience with like EFI. Yeah, certainly better than Carbies, that's for sure. It started first go. That was a big improvement.
Yeah, well, I don't know. Today I had to move both my GTVs around, and neither of them have started for a few months. And my 12P injected one. Turns out my NVRAM has passed its use-by date and wiped itself in the last 2 weeks. Whereas a carbide one that hasn't started for a few months either, just had to crank over a couple of times to let the mechanical fuel pump get through, and then it rolled into life. It took me an hour and a half to get the EFI one running.
Wow.
Yeah, I had this VP, just a spare parts car in the yard, and it was sitting there. I had the fuel in it was probably 3 years old as it was, and it was sitting in the yard for a good 4 months, and I just had a lawnmower battery sitting in it. I kicked it, just on like half a revolution of the engine, it fired up straight away. Yeah, so I reckon EFI is better.
Yeah, 99% of the time it is, but when you start breaking out oscilloscopes to work out why your 35-year-old car won't start, then you got to scratch your head a bit.
Yeah.
I had a question for Jamie. Are you still there, Jamie?
Yeah, I'm still here.
Yeah, what's that? On my screen it says Jamie Turner wants to show video, accept all videos on this call. What does it mean with that one?
That's a Skype thing. It means that I clicked my webcam and you have to allow it to look at the webcam. But that's been off for hours now, so...
It's on my screen. If I click that now, what happens? I'll click it now, see what it does.
Nothing.
Oh,
No,
okay.
nothing will happen now.
Yeah, no, I wasn't sure.
It's just left over from when
Okay.
I clicked the button at the start of the call.
Okay, very good. Yeah. Yeah.
Thanks heaps, Nige.
So we're no longer limited to 6,375 RPM.
Shit.
Do you know what it will actually do up to? I mean, I've with these the Motronics that I play with, I can get them to just the other side of 10,000 before they start missing counts. But they're doing a 60 minus 2 count, so they're probably going to drop out a long time before one of these.
Wow. I know an 808 is supposed to be able to do up to about 9,500, isn't it? I'll be able to test that soon. I'm a couple of weeks away from getting my 10,000 RPM motorbike engine running on 808.
Yeah, I was seriously considering converting my bike over to an 808 until I realised that the rev limit wouldn't cut it.
Oh, jeez.
Yeah, thanks, Nigel. Thank you very much.
Thanks heaps.